Here's the problem. I'd like to simplify this expression by combining the two series together into one. It looks like if I do that, I'm going to get some great simplification from canceling terms out, but I can't because the indices don't match up, right? Because they're starting and ending at different points. So in this lecture, we're going to look at how we can fix or reposition the starting and the ending points of a series by changing the variable. So let's think about what we want to do here. The index in the first series goes from 1 to 5, but I want to match it up with the other one. I want to make it go from 0 up to 4. In other words, I want to take every index and reduce it by 1. All right, well, to make that happen, I'm going to define a new variable, n, that's equal to k minus 1. And then where k starts at 1, n starts at 0, and where k ends at 5, n ends at 4, which exactly matches what the other series is doing. Now, to make the actual switch, I'm going to note that k is equal to n plus 1 and make that substitution in the formula for the first series. And this will become 2 times n plus 1 plus 1. We've got the sum here. Then I'll replace the index with n and change the starting and ending points to the corresponding ones for n. So now it's going to go from 0 to 4. And I'm going to leave the second one alone because the second one is doing exactly what I wanted it to do. All right, now next, notice the variable that I use for the counter doesn't matter. I can replace the k's in the original expressions with i's or m's or x's, and we still get the same result. So my last step before combining the terms is just to give them all a consistent variable. Let's say m, and I'm actually going to jump past this here, right? Because I went and boxed myself out of room. So let's jump down here, and I'm gonna make this the sum m equals 0 to 4. What does this simplify to? This will be 2m plus this becomes 2 plus 1. That's 3 plus still the sum m equals 0 to 4. Of negative 2m plus 1. Okay, now notice that I didn't just try to go back to k with the first series. If we didn't want to do anything else with the series beyond combining them together and simplifying them, yeah, we might have been able to get away with that. But if we have more we needed to do from here, it would potentially be a really bad idea to reuse a variable like that. Right? Better just to change everything over to a new variable that hasn't been used anywhere. Right? And now I can use our property from the last lecture and combine these two together. This is the sum m equals 0 to 4, 2m plus 3 minus 2m plus 1. And look at that. Yeah, I do get some great canceling here. This is the sum m equals 0 to 4 of 3 plus 1, that's 4. So what does that simplify to? Well, there's no variable. There's no variable over there anymore, right? In the expression, the sequence part. Well, okay. That's saying that this is always equal to 4. So when m is equal to 0, it's 4. When m is equal to 1, it's 4. When m is equal to 2, it's 4. And so on for all 5 of these numbers, right? 0, 1, 2, 3, 4, 5. So what this is saying is add up 5 4s. Well, if you add up 5 4s, what do you get, right? Well, that's it. I'm a little out of room here. I normally wouldn't go sideways like this. And that's just equal to 20, right? That would be our final result. Now, there is another way we could have approached this. Right? We can take the second series and just explicitly write out the first term. Right? When k is equal to 0, the first term over here is negative 2 times 0 plus 1, which is 1. And then keep the sigma notation for the remaining values from 1 to 4. Then I'll do the same thing on the other end of the first series. The last term over here, when k is equal to 5, is 2 times 5 plus 1. And I'll keep the sigma notation for the first 4. So what do I get here? This is 11. And now I can combine these two series together, because now, again, we have what we need where the starting and ending values match. Right? So if I do that, this becomes the sum k equals 1 to 4, 2k plus 1 minus 2k plus 1. 11 plus 1, that's 12, plus the sum k equals 1 to 4. What happens here? Now the 2k, the 2k and the minus 2k, they cancel, and we're left with 2. All right, so this looks a lot like it did on the last one. Right? This is how many terms are there in that sum? Well, 1, 2, 3, 4. Right? There's 4 of them. So what this is saying is add up 4 2's. Well, 4 2's, 2 times 4, that's 8. So this is 12 plus 8, which is 20. And look at that. Yeah, we did, thankfully, right? We did thankfully get the same answer either way, right? Both of these methods work. So this is the end of our quick introduction to series and the sigma notation. In the next series of lectures, we're going to switch back to thinking about proofs and see how we can apply this idea of a sequence to a special kind of proof called a proof by induction.